Hello everybody. I hope you guys are doing good. Today we are working on linear and absolute inequalities, and I will show you in college algebra they use different types of notations like interval notations, and you're also gonna have set builder notation. So I'm gonna show each one of them. Okay, let's start solving the questions. Interval notations. Okay, how do interval notation looks like? For example, I have A and B, and I have these parentheses. This is open interval, right? These parentheses means open interval, like it's a hole there. Or for the inequality, we use like this sign and this for a hole, like I'm just making that hole right there. And if we have this and that, it means that's a closed circle like that. Okay, so this means included, this means not included. So when you have these open parentheses, it means not included. This is a hole like this. So I'm just going to put these parentheses here so you know this is what it means. If you have included, it's going to be brackets. Okay, so don't confuse that. So A and B are interval notations. How do I write this as a set builder notation? So it's going to be something like this: the set of all x such that x is less than b and x is greater than a. This is set builder notation. Okay, now let's do for the closed intervals. If I have a and b and I have these brackets, that means closed interval, which means they are included. And how do I write a set builder notation? It's going to be the set of all x's such that x is less equal. Do you see I'm reading it from the variable side, like x less equal b, x greater the alligator mouth is towards x, then it means it's greater. The corner is towards x, and I would say it's less, and that's a. Okay, I'm gonna say this one more time up here with a different color. If I have x greater, do you see the alligator mouth is towards x, then I would say x greater than a. If I greater or equal, anything like that. If I say x, the corner coming towards the x, then I would say x less than a or equal a. So this is less and this is big or more or greater, whatever word you want to use. Okay, so these are set builder notations. These one, set builder notation. If the question is asking specifically set builder notation, then do that. These are interval notations. Okay, let's see what else we know. Now, if you have infinite intervals means I like infinity. You have infinity there, infinite intervals. And also I'll show you infinite set builder notation, intervals. Okay, infinite intervals gonna go something like this. If I have a and infinity, this means a and infinity can always gonna be having these parentheses no matter what. Okay, do not put the close brackets kind of thing for infinity, because you know infinity is not a defined point, it's not a real number. A means it's not included. Okay, so that's what it is. And for the set builder notation, you're gonna get set of all x such that x is greater than a. Everything's supposed to be greater than a, okay, because a is not included. Then we have another one, infinite interval. For example, if we have negative infinity and we have a b, I already said that infinity is going to have this parentheses because it's not included, not a real number, in case this b is included. Okay, so I'm going to say this b is included. There's a closed circle that's up here is not included, and builder notation is going to be x, the set of all x such that x is less equal b. So everything is going to be less than or equal to b. And do you see this equal and less than equal, that's why it's closed. So it's closed in an interval, or you can say it's a closed circle for this, and closed circle means brackets. Okay, so just pay attention to that. Now I can write it down here for you. Parentheses indicate the endpoints are not included. The bracket indicates the endpoints are included. Infinity is going to always have parentheses. They are not real numbers, not included. Okay. What else we need to know? Now, I have these few number lines up here. And for the number lines, the question was asking graph to find the set of 1, 3, both of them closed, which means included. Intersection of 2, 6 not included. Do you see? These are not included. These are included. So how do I graph? This 1 in 3 is a graph for this 2 for 1 in 3. This is a graph for 1 in 3, which is included. Do you see they are using the brackets right there? So from 1 in 3. This one is actually for 2 and 6, and they're not included, so they have these parentheses there. Do you see that right there? So it's from 2 to 6. What does intersection means? Intersection means which numbers between the 1, 3 set and 2, 6 set is common. Okay, it's common. So if you can tell, in this case 2 is included, right? And this is also 2. So 2 is common, and 3 is common. You see, 2, 2, 3, and 3. 1 is not there, and 5, 6 is not included in this one. So the only common ones are 2 and 3. So that's why we are. Do you see the 3 is included, and the 2 is not included because of that? So it's 2 not included, 3 included. Okay, so that's how this is gonna go. Let's try solving linear inequalities. Solving linear inequalities. I have a question. 2 minus 3x less equal 5. How do I solve this? Remember, I gave you in the beginning, I gave you 4 steps for solving the equation, and I said these 4 steps you are using for equation and inequality both, but inequality has one more extra step, step number 5. When you divide or multiply by a negative, this inequality sign is gonna be switching places, like it's switch direction, flips. Okay, let's solve this. Do we have fractions? Do we have, okay, if you want, I can write down the steps here for inequality. It was, first one was clear fractions. I'm just not writing a whole word, fractions, using LCD, least common denominator. Second, clear, I'm not writing the whole sentences because I have one video and you guys can go back and check that. Clear parentheses. Using distributive property. Third, combine like terms. Four, isolate variable. For inequality, you have a 5th step. This is extra 5th step for inequality. Okay. 5th step for inequality means if you multiply or divide by a negative number, you flip the inequality sign. Both of them, either one of them. Okay, so let's do this. Now, no fractions, no parentheses, isolate variables. So combine like terms. Combine like terms, then isolate. So let's do subtract 2 both sides. Cancel. And I'm left with negative 3x less equal 5 subtract 2 is 3. Now I have to isolate this x, and I'm dividing by a negative 3. When I divide by or multiply by negative number, you flip the inequality sign. So this is x, and I'm going to flip this like that. Look at this. 3 divided by negative 3 is going to give me -1 answer. And we are good. Now, how do I graph this? I have a number line here. This is 0, that's +1, and that's a -1, okay? Since it's a closed circle, because this is inequality, less equal, greater equal, you see this, greater equal, you have a closed circle and you use these brackets. So I'm gonna make a closed circle here. Now read from the variable side, x greater equal -1. Greater goes, when you use the word greater, it goes to the right. And that's how it's supposed to go. And you can make a closed circle, or you can make something like a bracket, like this one, -1, like a bracket. Do you see that? You can do that, and you can make an arrow that going in this direction. Either way is good. Okay. Let's solve another question for inequality. Another example, I have 3x plus 1, 3x plus 2. Now, this one doesn't have fractions, but does have parentheses, so I'm going to distribute. Positive times positive is going to give me positive. 3 times x is going to give me 3x. Positive times positive is going to give me positive. 3 times 1 is going to give me 3. Greater 3x plus 2. Now I did that, combine like terms. 3x and 3x are like terms. So you subtract 3x, we can jump over equal or any type of inequality. We have to use opposite operation, and this is what I'm doing. You can jump over just like that. So 3 is greater than 2. Okay, that's what I'm left with. This is a true statement actually. So I'm going to say the solution set is the set of all real numbers. Set of all real numbers. If the statement comes true, then you have all real numbers set. Okay, how do I write that? In interval notation, you're going to go -infinity to +infinity. When you have, and you know infinity has these parentheses, not brackets, always, always, always. So set of all real numbers means I'm going -infinity to +infinity. Whatever numbers I have, they are all my solutions. How do I set it up as a set builder notation? It's going to be the set of all x such that x is a real number. Simple as that. Okay. Close. This is what you get. Okay. Let's do just one more compound inequality. So compound inequality like one more than one inequality sign. Inequality. I have 1 less equal 2x plus 3 less than 11. How do I solve this? Now, do you see you have two inequality signs? It's called compound inequality. So what I'm going to do, I will solve this. I will make the x by itself. If I'm making x by itself, then you know that this term goes last. First, we have to get rid of this 3. So subtract 3 both sides. Okay, this cancel. I'm left with 2x. I'm not changing the signs, let them stay there. -3 plus 1 is going to give me -2. 11 subtract 3 is going to give me 11, 10, 9, 8. Yeah. Okay, what else I can do? Now I can x by itself, make x by itself. You divide 2 both sides. They cancel out. They cancel out -1. I'm still keeping that, and I'm dividing by a +2, so I don't have to flip the inequality sign or anything. I'm going to keep them as it is. So this is my answer. Okay, if I do interval notations, then interval notations means, do you see this -1 has less and equal, like x greater equal -1? It means that -1 is going to have a bracket. It's included, closed circle. And this is not included, so it's going to have a parentheses. There you go. This is called interval notation. let's try set builder notation. And do you see this? This is already, I got it. This is, you can just put this in the set builder notation, like something like that. The set of all x such that, and you just put this in, x less 4, x greater or equal -1, close the set, and you're good to go. Okay, that's how you do it. Let's do how to solve absolute value inequality. We did the equations, but let's do absolute value. So I'm going to draw a line here, and we're going to do absolute value inequality. Okay, I'm going to give you an example here. I have 18 less than absolute 6 minus 3x, absolute close. Remember I said in the beginning when I was doing absolute equations, I said make sure that radical equation, like a radical values and the absolute value, you make them by itself before you go further. And this is already by itself. So all I have to do is take it out from the absolute, keep the sign in 18. Then I'm using make sure the x by itself, so don't touch this first, do that one first. -6, -6. You know this is not wrong if you do -3, divide 3 everywhere, but you will have some extra steps. I don't want it. 18 subtract 6 is gonna give me what? 18 subtract 6, 18 subtract 6. It's gonna give me, is it gonna be subtract? 6 minus 3x, and you subtract, it's gonna give me 12. Yeah, I'm right, -3x. For a minute I said, okay, I'm just doing something wrong. Then you divide -3 both sides. I'm dividing by negative number, people. It's gonna go and flip this. So, okay, let me not do this. I'll change it later. You're gonna get confused. So I'm gonna keep this x, and I'm gonna flip this. You see the sign flipped the direction, and that would be -4. Now I can, since I like my x values, the variables x's, y's, whatever on the left side, so I'm gonna switch this. Do you see this x has a corner towards it? I'm gonna make sure that corner is towards x and -4. So that's that answer. And you know that absolute has two answers, like one negative, one positive. So how do I deal with that one? What are you gonna do? Are you gonna, I can switch this, like I can do 6 minus 3x absolute, and you know this alligator mouth is towards absolute, so I'm gonna make sure that it's towards absolute, and I have 18. I just like them in this side. Look up here. Now, how do I change for the second one? Remember in the previous equations inequality, we were making this last one negative. So how do I do this inequality? In inequality, you're going to do something like that. 6 minus 3x, you're going to change the direction, and you're going to say minus 18. Do you see that? For inequality, that's the only one thing right there. Then you add 6 both sides, add 6 both sides. Right? So if I add 6 both sides, I'm gonna get -12, right? -12, yeah. This is cancelled, -3x and -12. Now I'm dividing by -3 both sides. Again, I'm dividing by negative. I have to switch the inequality sign, and it's gonna give me +4. There you go. So x greater 4, x less -4. Okay, that's cool. Okay, that's how we do it. For the what is it called, set builder notations, I can do something like that. Okay, watch. It's gonna be x, set of all x such that x, the small number goes first, like a -4, x less -4, and you're gonna say or x greater than 4, close. When you get something different, like some two answers separate, then you have to have that or thing there. Okay, so we are done with this objective, guys. Make sure that you remember when I did the absolute value equations, make sure that you have two things, like one negative, one positive answers. Like the answer when you have absolute equals something, that equals something supposed to be one positive, one negative, and you solve the problem like a regular. But make sure before you start solving, the absolute equation supposed to be by itself, like isolated. Now for inequality, I'm doing the same thing. Like this is already isolated, so I got the answer like simple. But another thing has to be negative 18. So for the negative, you also have to flip the inequality sign. Okay. Okay, guys, have a good day. Any questions, please make sure that you ask me in the comments, like my videos, and subscribe. That would help me. Thank you so much. Bye.